Hi to all. Today's topic is LC oscillations. L means inductor, C means capacitor. Inductor capacitor oscillations. What is this? Actually, in the 11th class, you studied about the oscillations of simple pendulum and oscillations of loaded spring. Okay, let us see here. I will explain. And this is a spring, and for this we are hanging some load, and when we pull down and release, right, then it will do the oscillations. It will goes up and down. Okay, and this position is said to be mean position, and now we pulled down little bit and then release it. When it comes to here, it has the potential energy, maximum potential energy, that is the half kx square. The potential energy become maximum. Here the kinetic energy is 0. We release that here, initial velocity 0. Now it will go like this, and when it come to here, what happens? Its potential energy decreases and it will become 0, but the kinetic energy become maximum. With that kinetic energy, it will goes upward, and then at this location, and then again the potential energy become maximum and kinetic energy become minimum. That means while doing the oscillations, the potential energy convert into kinetic energy, and the kinetic energy convert into potential energy. The total energy remains constant. And now this to and fro motion or up and down motion, right? And in this, the acceleration of the loaded spring is always directly proportional to its displacement in opposite direction. Then we say that oscillations are in simple harmonic motion, and in the simple harmonic motion we have the equation, that is A is equal to minus omega square y, or x we can also write displacement. If acceleration we write as A is equal to dv by dt, we write rate of change of velocity, and velocity we write as rate of change of displacement. Okay, then the general equation of SHM we write as like this, that is d square y by dt square plus omega square y is equal to 0. This is the equation of SHM. Equation of SHM. Okay, right. And now what we learn it here, just I will revise. Okay, this is a loaded spring, and when we pull down and release it, it will do the oscillations, and in this moment its potential energy convert into kinetic energy, and kinetic energy convert into potential energy, but the total energy remains constant. The same thing will happen in the LC circuit that I am going to explain now. Look here, I am taking the one inductor. This is the one capacitor. It is the fully charged 2 plus Q naught and minus Q naught. And after that it is connected to some inductor. This is the inductor. When it is fully charged, then in that the energy stored is said to be electrical energy, right? It is the positively charged. This is the plus, 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 and this is minus, minus, minus. Now a capacitor is fully charged. The Q naught is the maximum charge on the capacitor. Q naught is the maximum charge on capacitor. Maximum charge on capacitor. Okay, and energy stored in the capacitor formula is what you know already. Energy stored in the capacitor, energy stored, okay, that is electrical energy. Energy stored in capacitor, that formula is Q naught square by 2C. Okay, right. And energy, this is in the form of electrical energy, right? Electrical energy. And then if some current I current passes through the inductor, the energy stored in the inductor formula is energy stored in inductor is, that is the magnetic energy stored. Its formula is half Li square. This is the magnetic energy. Okay, right, let us see here. First, a capacitor is fully charged to Q naught. That means electrical energy is maximum. That electrical energy formula is Q naught square by 2C. Here the charge C is the capacitance of the capacitor, Q naught is the maximum charge, that's why electrical energy is maximum. And what about the magnetic energy? The magnetic energy in the inductor is half Li square, but in the beginning when we connect to the capacitor which is fully charged to the inductor, okay, firstly capacitor is fully charged and then it is connected to the inductor. At that moment the initial current in the inductor is 0, right? That's why the initial energy stored is 0. This is the first case that we are observing. And after some time what happens? Now the current starts to increase in the circuit because the capacitor starts to discharge. That's why the second diagram will be like this there. This is the second diagram. I am going to draw it here. This is the capacitor. At any instant of charge, this we can take as plus Q and minus Q. And now the current, this is the inductor. Inductor means just it is a coil, we are connecting like this. Okay, look at here. When the capacitor starts to discharge, for example here 10 microcoulomb is there, after some time the charge will be decreases to 5, 4, 3, like that the charge will be decreases, right? And here at any instant of charge, the charge we can consider as Q. This is the plus and here minus. The charge will be decreases, right? The charge will be decreases in this. That's why when it will starts to discharge, the charge decreases in this. The current flows like this through the inductor. The current is increasing it here, right? At any instant of time, the current is I, its inductance is L. Then we write here the energy stored in the inductor, right? This will act as a north pole and this will act as south pole. And this, when the current passes through the inductor, it will act like magnet. And then we can draw the magnetic lines like this. In this case, what happens? The energy stored in the electric field become, charge is decreasing it here because it is capacitor starts discharging. When it starts discharge, some of the charge passes through the inductor, that's why it is discharging. When the charge passes through the inductor, then the charge on the capacitor will be decreases, that's why some current passes. The energy stored in the in the capacitor, in the plates of capacitor, right? Q square by 2C. This is not equal to 0, some value, right? Magnetic energy stored in the inductor also not equal to 0 because some current is passing it here. This is also not equal to 0, right? Both are not equal to 0. This is the second case that we are observing in this case, right? Now the next one I am going to draw, right? The next case, what happens? Firstly, the fully charged capacitor connected to the inductor. Initially there is no current, that's why the total energy stored in the capacitor, and now it start to discharge. When some charge passes through the inductor, some current passing, that's why when the current passes through the inductor, it will act like magnet, and some magnetic energy stored in the inductor. That magnetic energy stored is half Li square, it is not equal to 0, and energy stored in the capacitor is also not equal to 0, right? Because the totally it is not discharged, right? And the next, what happening, this third case I am going to explain. The third case is that though the capacitor is fully discharged, when the capacitor is fully discharged, right, then the charge on the capacitor becomes 0. The charge on the capacitor becomes 0, and but when the charge on the capacitor becomes 0, then the total charge becomes 0, means the total charge is sent to the circuit. That's when the current in the circuit become maximum, right? When the current becomes maximum, what happens? when the current becomes maximum, the energy stored in the inductor also becomes maximum. Okay, then when the energy stored in the inductor becomes maximum, the lines will be like this there. Field is more because the lines are more. The field is strong and it is very near. The lines are close means the field is strong. This is the magnetic field. In this case, let us see what about the electrical energy stored in the electric field. Energy stored in the electric field formula is Q square by 2C, but the charge is 0 at here. That's when the capacitor is fully discharged. Then the charge becomes 0. Energy stored becomes 0. It is minimum, right? And but the magnetic energy stored, maximum current passing in the circuit. That's why the magnetic energy stored in become maximum. What happening it here in these first three cases? Firstly, the capacitor has maximum energy, inductor no energy. Then next case, some of the energy transferred to the inductor. That's why energy shared between the capacitor and inductor. That's why both are not equal to 0. After some time, capacitor fully discharged. That's why the energy stored in the capacitor becomes 0, but the energy stored in the inductor become maximum. In the next case, what happens here? There is no charge to send again through the circuit or through the inductor because the capacitor is fully discharged. Now the current in the circuit starts decreasing. The next case is that the current in the, this is the fourth case, this is the third case. Next I am going to explain the fourth case. What is the fourth case? Okay, look at here. This is the first case, this is the second case, and now the third, fourth I am going to explain. That is the fourth is that this is the capacitor. And now the current in the circuit starts to decreasing because there is no other additional charge to send through the circuit. Then when the current decreases in this, automatically, right, the charge decreases. That charge will be stored in the inductor. That means now the maximum energy stored in the inductor, that in the capacitor energy becomes 0. That's why this inductor starts to supply the energy in the form of electrical. That means the magnetic energy stored in the inductor convert into electrical energy, then it supplied energy to the capacitor. Now the capacitor starts charging, okay, then here the current is decreasing. Some current at any instant of time, the current we can consider as I. Okay, current starts to decrease, and now the some charge stored at here, that is considered as. Here what happens, the terminals will be, polarities will be changes. This will become minus minus and plus plus. Why? Because here when the current passes at here, electrons goes in opposite direction like this. Right? When the current, it is discharging means it is different. Discharging means it is electrons goes like this. Okay. But it is discharging on that. It is now charging. Charging means then the electrons goes, when the current goes this side, electrons goes opposite direction, then electrons comes like this and stored on the plate of the capacitor. That means here negative is stored and here positive is stored. Now what happening, the energy stored in the inductor is decreases, energy stored in the inductor decreases. Energy stored in the capacitor increases. This will become like this. The energy stored in capacitor Q square by 2C. This is not equal to 0. Energy stored in magnetic field. This is also not equal to 0. Right? Okay, this is the fourth case. What happening at here? Right? Energy is exchanging between the capacitor and inductor. Let us go for the some other case. What I wrote it here, a capacitor is fully charged and connected to the inductor. Then energy exchange between the capacitor and inductor. That means if the capacitor is fully charged, initially the capacitor has maximum charge. When it starts to discharge, then the energy in the capacitor decreases, energy in the inductor increases. After some time, then the both have this nearly equal energy. After some time, what happens? The energy in the capacitor again becomes zero, but energy in the inductor become maximum. Now inductor energy starts to decreasing and the capacitor energy starts to increase, right? Okay. Now that means capacitor discharges and then after that charges. Then here the charge and current oscillates. Charge value is increasing and decreasing. Current value is increasing and decreasing. That means it is oscillating. This oscillating charge and oscillating currents can produce the electromagnetic wave. Here EM wave I wrote. Okay, right. And you know all these things, and then after that I will rub this one and you note, take the screenshot and note it. Next case we will see. Fourth case, what happening? Fourth is completed. Fifth case, let us see. Fifth case. Then further purpose, what we have to do? Again we have to take the capacitor. This is the capacitor. This is the inductor. Right, the capacitor now it is fully charged. Okay, some more charge, current is decreasing it here. First current 0, next increasing, become maximum, next current decreases. Current decrease means energy stored in the inductor decreases, because energy stored in the inductor depends upon the current. And the next current becomes 0 in the circuit. Okay, then at that moment the capacitor is fully charged. Capacitor is fully charged, but it will be oppositely charged. And then in this case the current in this inductor is 0. That's why the energy stored in the capacitor is, that is electrical energy, U suffix E, that is Q naught square by 2C. This will become maximum. And then magnetic energy stored in the inductor is half Li square, but the current is 0. That's why energy stored in the 0, this is minimum. Okay. These are the diagrams, some diagrams that we are having. That means firstly the capacitor has one plate is positive charged and negative charged, but after some time what happens, the capacitor one plate become negative and the next plate become positive, right? And after that what happens, again this capacitor fully charged now, then it starts to discharge. It starts to discharge. The current passes like this, right? And the reversely magnetize, and then again the process will be reverse, right? And at that moment the energy stored in the capacitor becomes 0, energy stored in the inductor become maximum. This continuously the charge on the capacitor decreases and increases. Like this, the energy stored in the inductor converted into magnetic energy, and magnetic energy stored converted into electrical energy. That means energy is oscillates between the inductor and capacitor. Okay. And if you draw the graph between, in this case, if we draw the graph between the current versus or the charge versus charge or current versus time. Okay, we will get the like this. Energy exchange between the capacitor and inductor. But in the reality, in the practical, right? In practical, but energy not constant. Okay, energy why it is not constant? Because every inductor has some resistance. Inductor has some resistance. Due to that, conservation of energy not possible. Due to that, energy losses in the form of heat. In in the form of heat. The second case is that energy radiates in the form of EM wave. Even though if the inductor not have the resistance, but energy radiates in the form of EM wave. Okay, because here what happening, this will generate the varying magnetic field. When the current varies in the circuit, then it can generate the varying magnetic field, because the magnetic energy stored in this formula is half Li square. When the current varies in the circuit, the energy stored in the magnetic field varies. When the magnetic field varies, that magnetic field has capacity to generate the electric field. Varying electric field, varying magnetic field in the space, if they will generate, then they can move. That is said to be electromagnetic wave. In this wave, this LC circuit is also used to generate the electromagnetic wave. Here electromagnetic wave will be generated. That electromagnetic wave is used in the communication. How the electromagnetic wave is generated? Here what happening, this inductor is generating the magnetic field in the space. That magnetic field is varies because current is varying, and because energy stored in the magnetic field depends upon the current. When the current varies, magnetic field varies. When magnetic field varies, then electric field generates, varying electric field generates. Varying electric field can generate the varying magnetic field. Like this, in the space, the magnetic wave energy generates it here, that will travel like this. But in the practical, the energy is decreases with the time because of, right, due to above reason, right, because of inductor has some resistance, energy is not constant. Like this, oscillations will be damped out. Oscillations damped means their amplitude is decrease amplitude, or die out. Why? Because of due to above reasons. Energy not constant. And oscillations die out. Okay, right. This is about LC oscillations. It is a qualitative study. In this, energy stored in the inductor and capacitor is oscillating, and then we have to derive the frequency of oscillation. It can generate the EM wave with certain frequency. That frequency formula we have to derive. In the next continuation we will discuss.